very good morning to you all.
Good morning, teacher.
Last time we discussed vertical motion. We did proofs of vertical motion. Today we would like to introduce another kind of motion, which is called motion on an inclined plane. Motion on an inclined plane. So, for motion on an inclined plane, if you take a look at an example, if you look at this board, and I place there this roller, when I release it, the roller slides down. We need to ask ourselves, why is it that when it is like this, it is not rolling when it is horizontal? But if the board is inclined at an angle, it behaves like an inclined plane. So anything can easily slide or can slide on an inclined plane because of the reasons we are going to see today. And that motion is facilitated by equations of motion. But this time round, the acceleration is not as it is in vertical motion. Also, the acceleration is not as it is in linear motion. It is slightly different. The only argument we shall see is when it is sliding down, the acceleration is still positive. When it is sliding up, acceleration is negative, as we are going to see. So, with this reason, we can say consider. If you consider a particle moving along an inclined plane of inclination alpha to the horizontal. The horizontal. Then we need to resolve the gravity G into two components, i.e., one along the plane, then two perpendicular to the plane. So, what are you trying to say here? What we are trying to say is that if a body is moving up an incline, like you've seen, if I release this piece, this white piece, it slides down. I'm not pulling it down. This is pulling it down. But if I do this, it is sliding freely. So there is no force that is pulling it down apart from the component of what we call mg sine theta, which I'm going to show you. Now, what happens is, if this body is on an inclined plane and the body is right here, then this body has its vertical component of the weight, which is mg. The weight of the body always acts down, vertically downwards, no matter the situation. Now, another component, because this is a surface, on surfaces of bodies, if you have a body on a horizontal surface, this body experiences one, a normal reaction, then two, it experiences its weight, vertically downwards. But the normal reaction is always perpendicular to the plane. So even here, we shall have a normal reaction coming from the body, which is perpendicular to the plane. If I draw a parallel line to the plane, the normal reaction is always perpendicular to the plane R. Now, what happens is we have to resolve the weight parallel to the plane, and we have to resolve the weight perpendicular to the plane. In that sense, I'm going to resolve my weight in this sense. This is perpendicular to the plane. This is parallel to the plane. Now that is where the mathematics is. We need to know what have we done to get those ready components. If this is where the weight was mg, and this is alpha, the angle up here will be 90 minus what? Alpha. If this is 90 minus alpha, remember there's a normal reaction here, R, which R is also protruding up to this way. Now the whole of this angle is 90. There is a balance here of alpha. So when I compress the weight, if I have this is alpha, and I have this as mg here, then down here I'll have mg cos alpha. Then opposite to the angle, I'll have mg sine alpha. So ideally, the mg is compressing the angle as it goes down. So even here, this mg is compressing this angle. So this becomes mg cos alpha. Then for this one, you're moving away from the angle to move to the vertical for this mg sine theta because of the right angle triangle. So definitely perpendicular to the plane or parallel to the plane, you will have a component which is running down as mg sine alpha. So with that note, the components of the resolved forces will be, here we shall have mg cos alpha, then here we shall have mg sine alpha. From today onwards, those components in blue, they are the forces which act on a body perpendicular and parallel to the plane. So parallel to the plane is like this pen and this white plane. The pen behaves like the mg sine theta. Whereas perpendicular to the plane, this is the normal reaction, but there is a component which has gone inside the board down under my hand. It is invisible. That's why we show them with the dotted lines, because they are resolved components. Now, the reason why this body slides down is because mg sine alpha is pulling it downwards. And if there is no force overcoming it, the body will slide down. Now, because this way there is no force acting upwards here, look at this point. Because there is no force this way, it means when sliding down, comma, mg sine theta overcomes nothing to give us the resultant force, ma. It is from this note that mg sine theta is equal to ma. So you can divide by m, and finally acceleration is always g sine. This is alpha, not theta. Acceleration is always g sine of alpha when the body is going where? Downwards. That is what we wanted to derive. You can cram that and forget all I've mentioned so far if it doesn't give you any good comfort. Only what I wanted is to derive how the acceleration looks like. Then the second one, when going up the plane, what happens? Because you saw there is no force pulling it, so 0 overcomes mg sine of alpha to give us the resultant force, which is mass times acceleration. Therefore, negative mg sine of alpha is equal to ma, I divided by m. So when a body is moving up the plane, acceleration is a negative g sine of alpha. These are the accelerations I wanted to derive, and those are the accelerations for a body that is moving on an inclined plane. We shall discuss more about those forces and those inclined planes in the future. But now we just wanted to see how does the acceleration look like when a body is moving on an inclined plane. You see cars climbing hills, you see people walking on a hill, you see people running on a hill, you see bodies that are moving on a hill, animals, cows, vehicles, motorcycles. How do they move? They move with this acceleration. If they are to move freely, without powering them, without switching on the engine, because we shall look at work, power, and energy, it will change this. But if it is a free movement, like I showed you, this is sliding freely. Nothing is pulling it. It's just that it is on an inclined plane, so all it has to do is to slide down. So it slides down with G sine alpha. Therefore, the equations, hence, the equations of motion on an inclined plane are one. Remember vertical motion. V is equal to U plus GT when the body was going up. So here we shall say V is equal to, when the body was going, when the body was going down, V is equal to U plus G sine of alpha times T. Then S was equal to UT plus a half GT squared, whereby S is going to be equal to UT a plus a half GT squared sine of alpha. Then V squared is equal to U squared plus 2GH. This is going to become a V squared is equal to U squared plus 2G sine alpha times H. This is when a body moves down. And incline. Then when a body moves up an incline, from V is equal to U minus GT for upward motion in vertical motion. Here we shall have V is equal to U minus GT sine of alpha. S is equal to UT minus GT squared over 2. Here we shall have S is equal to UT minus GT squared sine of alpha over 2. Then here we have V squared is equal to U squared plus 2GH. And then minus 2GH, we shall have V squared is equal to U squared minus 2G sine of alpha times H. H can be the distance it has moved along the inclined plane. So in this case round, these equations are used when the body moves up the plane. When a body moves up the plane. Okay. This occurs when the body moves up the plane. So any questions here if I can proceed to examples? Yeah. Do you have any questions? Yes. So if no questions, let's take a look at an example. So that let me first power my laptop. Okay. So the first example says, Example 1. A particle sliding down a smooth inclined plane .6 meters long acquires a velocity of 6 meters per second from rest. Find the inclination of the plane. Find the inclination of the plane. Now, they have said we have a particle sliding down a smooth plane. We do not know the inclination, it can be theta, but this particle is going to slide down. So before you do any other item, if it is to slide down, it starts from rest, so initial velocity is 0. Yeah. Now, we have already seen that if it is sliding down from v squared, we have initial velocity, it is going to reach here, attains a velocity of 6 meters per second. Yeah, and by this, it has traveled what distance? 3.6 meters. So we can use the equation of v squared is equal to u squared plus 2g sine alpha times x, the distance it will have traveled. So v squared is 6 squared is equal to initial velocity 0 plus 2 times 9.8 sine of theta, because our angle is theta, times the distance, which is what? 3.6. Now, can you make sine theta the subject? It will give us 36 divided by 2 times 3.6 times 9.8. When you divide 3.6 by 36, the answer is 10. So this will give us 10 divided by 19.6. You see that theta is sine arc of 10 out of 19.6. Partly the return of trig. I told you trig is coming, so it's already here in inclined motion. So has someone compute for us and get the answer? Lutula, give me the answer.
36.67. 36.67
degrees. Angles to 2 decimal places. Now, there is another method I can use. Or, that is if I've used equations of motion. If I've not yet decided to use equations of motion, I can decide to go and use my forces. Though we shall have another topic of forces, depending on these. Forces, we show that there is always those 2 components of forces, which are the main forces. Then we have a resolved component, which I said we can grab as mg cos theta. But we should know how it comes about. You never know, you might teach in VAC. Then this one is mg sine what? Theta. But as mg slides down, you will have mg sine of theta overcoming nothing to give us the resultant force, mass times acceleration. So the acceleration would become 9.8 sine of what? Sine of theta. Then of course, when you get 9.8 sine of theta, you go and substitute, and you'll have, you can have from V is equal to U minus GT plus GT of sine of theta, you can find the time and say the velocity is 6 is equal to 0 plus 9.8 sine of theta times time. Then you can see that time is equal to 6 divided by 9.8 sine of theta. Then when you go for the other equation, S is equal to UT plus a half G sine of theta over T squared, you'll get 3.6 is equal to 0 plus a half times 9.8 sine of theta times T is equal to 6 squared out of 9.8 sine of theta, but the whole of this one is squared. So I can divide off this and I leave it with 1. So this, I take the sine theta up, I'll get sine theta is equal to 6 squared out of 2 times 9.8 times 3.6, which is the same as that one. Therefore, theta is sine arc of 36 out of 7.2 times 9.8. The answer must definitely be the same. Is it the same answer? I guess it is. Hope you have got the same answer, right? Girls, is it the same answer? Someone confirm.
I got it as 30.68.
Are you sure?
Yes, and also on the other theta for the other side, I got 30.68.
Even this one I doubted a little. Okay. So it is 30.68. Even here it must be 30.68. The rest, do you confirm?
Yes.
Okay. We need to confirm those answers so that we do not have deviant answers. Okay, let's have another example, which is example 2. A particle is projected with a velocity of 20 meters per second up a smooth plane of inclination 30 degrees. Find the distance described by the particle. and time that elapses when it comes to rest. Now, this time round, the particle is projected up a smooth plane of inclination 30, meaning it is projected from down. I don't know if you can see me in the image. It is projected like this. So it goes up and stops, perhaps, and slides back. But our intention is its motion as it goes up. What happens? You see that? It goes and stops. So I project it from down by pushing it or giving it some initial velocity, and then it goes upwards, and then it comes to rest. So they're asking you find the distance described by the particle and the time that elapses. So as you look at this, this is what is going to happen. When you're given the angle, you write it down. You project the particle from the bottom, it goes upwards with an initial velocity of 20 meters per second. When the particle goes up with an initial velocity of 20 meters per second, it is going to cover a distance we don't know. It is going to stop somewhere around here. Okay, so the acceleration is actually, because it is going up, it's a negative g sine of 30, which is the same as, you can either use that from the word go, or you can say it's the same as a is equal to a negative g over 2, because sine 30 is a half. You must be trig machines now. Yeah? So the first question wants to find the distance. So from v, we know v is 0 because it is reaching final velocity. Initial velocity is 20. So from v squared is equal to u squared minus, okay, plus 2gh plus, okay, plus 2as, which is 2ax. We have already seen what the x is all about. Therefore, we shall have v squared is 0. Then the u squared is 20 squared, a plus 2 times negative g out of 2 times x. It is the same if someone continues with the other illustrations we had before, the equations. So finally, we shall have 0 is equal to 400 minus gx, because I'll lose this 2 with this 2 by division. Therefore, x will give me 400 divided by g, which gives me 400 divided by 9.8. Finally, my x is equal to 400 divided by 9.8. What do you get? We get 39 points. Not 39, it's actually more than 30. It's around 40 points.
$40.82.
Only
8163.
81, that is the answer. 8163, 4 decimal places. Meters. Unless they have told you to write the answer to 2 decimal places. So that is the distance. Then the second question says, find the time that elapses when it comes to rest. We can just use in equation, both equations. From v is equal to u minus gt sine theta, if you remember that one. Final velocity is 0, initial velocity is 20, minus 9.8 times time times sine of 30. So this is equal to 0 is equal to 20 minus 4.9 t. Where is the 4.9 coming from? Sine 30 is a half. So t would become 20 over 4.9. 20 divided by 4.9, the answer is approximately 4 point what?
$4.0816.
4.0816 seconds. I've told you can use 2 methods. That is the method of the first equation of motion. What if I use the method of the second equation of motion, as it also has time, which is S is equal to UT minus GT squared sine of theta over 2. I will have the distance I've already got, 40.0.8163 is equal to the initial velocity, which is 20 times t, minus 9.8 over 2 times t squared times a half. Where does the half come from? It comes from 20t minus 9.8 divided by 2 times t times sine of 30. So this gives me a 4 as the denominator. This will give me 40.8163. And multiply everything by 4, 80t minus 9.8t squared, so that I remove the denominators. 9.8t squared. This is now just simple algebra of simplifying, which we have done in paper 1, pure math, plus 4 times 40.8163. What do you get?
Six 163.2652.
163.62.
0.2652.
0.2652. Okay, can you press using a calculator and get me the answer? But if you want to show that you have worked out, because you have to show the working, you say it's positive 80 plus or minus using bulldozer, 80 squared minus 4 times 9.8 times 163.2652, all divided by 2 times 9.8. Someone put that in a calc, give us the two answers.
The first one is 4.0849.
4.0849.
0849.
0849. Then the second one.
4.073.
Eh?
4.0783.
4.0783. Yeah? These are the answers. Eh?
Yes.
Ah, okay.
Yes.
Because of this 7, because the answer in the book, if you are dealing with the book was saying the answer was 4.08 seconds. When you truncate this one, you get 4.08. When you round off this one, you get 4.08. So ideally, the answer is the same. So it's ideally, I think we have just missed some decimals around there. That's why the answer is slightly different. But if it was using, for example, G is 10 consistently throughout. If G was 10 here, you would have got what? 40. Then even these others would be consistent. So you all end up coming up with the same answer. So sometimes,
Teacher,
yes, please.
I'm getting 0.4082.
0 point.
408.
Actually, the answer in the book is what, 4.1. The answer is 4.1 seconds. They wrote 2 decimal places. But because of our marking in UNEB, we have to write to 4 decimal places. Now, this lady is saying she's getting 0 point.
4082.
4082. You must have missed a decimal somewhere. When you put in a calc, eh?
Yes.
Can you repeat it again? Go to where quadratics are, put A is 9.8, B is -80, and C is 163.2652.
Yes, I've got it.
Okay. This one is yours. A particle slides from rest down a smooth inclined plane. 12 meters and 2.5 meters high. What is its velocity on reaching the ground? And how long does it take to reach there? How long does it take to reach there? That one, try it out. As you try it out, I want you to take a screenshot of these numbers. They are numbers due to motion. They are on. They're in Humphrey. I mean, they're in this book. Take a screenshot. I take you back to the white page. Take a screenshot here. You can do the following numbers. Let me mark them. You can do number 1, leave number 2, leave number 3, do number 4, do number 5, do number 6. Particle moving arrow starts with the 4. Do number 7, do number 8, do number 9. This one for vectors, first leave, this one leave, this one do, this one do, this one do. so that you also know that the world is not a simple thing. Let me see if I have one more here. Those ones can be enough, okay. But if you have enough time, now the rest are yours. Those are assigned by the teacher. The rest are yours. So screenshot that. Have you screenshotted that? So let's take you back. Those who have smart, good phones, you share also on the group. Let's go back to our page so that people do the number. Go ahead and do the number, guys. Welcome, Salam. Hello? You screen share your work on WhatsApp. Answer? One person I think has brought an answer. Let me check her answer. She is who? Mas, I think you overrounded off somewhere, but your answers are okay. Sometimes you wave these answers. Can I have another person? Another person with an answer? The rest, I don't see your inboxes.
So just a minute.
Okay. Thank you, Message Sachi, for the good thoughts of the way you've handled the number. I'm impressed. As people are still battling with that one, let me also put another one which you can screenshot to maybe have also later. It was activity 1, activity 2. This one is a proof. And that number, I think, is from Humphrey. Guys, time is overflying. You have approximately 7 minutes. Why are people taking so long? Master, you can try out the other second one as people are trying out that one.